Hey, so we're going to get started and talk about Newton's second law of motion. So, what is Newton's second law and what exactly does it mean? Why are we learning about this? Why are we talking about this? Well, Newton's second law says that force is equal to the mass times the acceleration. A lot of times you'll just see it written as F equals ma. So F is force, m is mass, a is acceleration. So remember, acceleration is a measurement of how quickly an object is changing speed. So it could be changing speed going from 0 meters per second to 5 meters per second to 10 meters per second to 15 meters per second every second. That would be kind of a slow increase in speed. You could increase the speed much faster. You could go from 0 meters per second to 10, 20, 30, 40. That's a little bit faster increase in the speed, so a greater acceleration. All right, so what does F equals ma mean? So remember, force is directly proportional to mass and acceleration. So we're going to imagine there's a ball of a certain mass moving at a certain acceleration. This ball has a certain force. So kind of ambiguous, I know, but if a ball has a mass, if it's moving at a certain acceleration, this ball does have a force about itself. So now imagine we make the ball twice as big. So we would essentially be doubling the mass, but keep the acceleration constant. F equals ma says that this new ball has twice the force as the old ball. So remember, we're using F equals ma. And if we make the mass twice as big, so 2m, there's twice as much as mass, then, of course, force is going to be twice as big as well, because it does have to be proportional. Or imagine that this original ball moving at twice the original acceleration. So again, original equation, F equals ma. And this time, it's twice the amount of acceleration. So times twice the amount of acceleration. So this equation says that the ball will again have twice the force, because what we do on one side we have to do on the other. This equation is always going to be balanced. The force is always going to be equal to the mass times whatever the acceleration is. All right, so we've already said if you double the mass, you double the force. If you double the acceleration, you also double the force. What happens if you double the mass and the acceleration? So we have twice the amount of mass, then we have twice the amount of acceleration. 2 times 2 is 4, so we would have 4 times the amount of force. So doubling the mass and doubling the acceleration quadruples, or times 4, so it's 4 times the amount of force. So what would happen if you decrease the mass by half? How much force would the object have then if you decrease the mass by half? Think about it. Well, compared to this situation up here, if you decrease the mass by half, well, right now the mass is 2. If we decrease it by half, we would have 2, right? So half of 2 is 1. So we would have 1 for the mass times still 2 for the acceleration, because we're not changing the acceleration. So times 2 for the acceleration, and that's going to give us 1 times 2 is 2. So 2 for the force. So our force, what happened to it? Well, it went from 4F to 2F. So when we halved the mass, it now halves the force. So whatever you do to the mass, it's going to directly affect that force. If you double the mass, you're going to double the force. If you decrease the mass by half, you're going to be decreasing the force by half as well. Okay, so F equals ma basically means that the force of an object comes from its mass and its acceleration. So however much force an object has, it's directly because however much mass it has. Is it a lot of mass? Is it a little bit of mass? Or does it have a fast changing acceleration or a slow changing acceleration? Is there an acceleration? So think about something very massive. So it's very massive. It has a high mass. that's changing speed very slowly. So maybe 1 meter per second, 2 meters per second, 3 meters per second, 4 meters per second. Changing speed very slowly. So very low acceleration. So the example we could be talking about a glacier moving. Of course, it takes hundreds of years for a glacier to move any significant amount of movement, but because it has a high mass and a low acceleration, it still has a great force. So if you've ever learned about glaciers and you know, yeah, they move super slow, but they're so massive that as they move, they scrape into the ground and leave deep ridges into the ground. Glacial scarring almost. So you'll have to look that up. Pictures are pretty cool. All right, another example. Sometimes something very small, so something very small would have a low mass, that's changing speed very quickly. So some sort of high acceleration. Like this bullet, it's ejected at 0, 5, 30, 50, 100, 150 meters per second, probably faster, but I have no idea. But obviously you get the point, changing speed very quickly, very high acceleration. It can still have a great amount of force. So although this bullet obviously has a very low mass, it moves extremely fast. It has a very high acceleration. So it still has a great force. All right, so let's review. Way back when we talked about Newton's first law. So try to think about Newton's first law and put it in your own words. It should be something similar to objects in motion tend to stay in motion. Objects at rest tend to stay at rest unless some sort of unbalanced force acts on them. So remember whenever we talked about this law, we talked about inertia. Inertia is the resistance to change. That if an object is sitting, it's going to keep sitting. Inertia. If an object is moving, it's going to keep moving at that constant speed. So maybe cruise controlling through space, cruise controlling down the road, some sort of constant speed, unless some sort of unbalanced force acts on it. And remember, we've talked about unbalanced forces. That means that our net force is greater than 0. Could be 1, could be 10, could be 150. All right, Newton's second law, we just talked about this. You should definitely be able to put this in your own words. So pause for a second and see if you can. All right, force equals mass times acceleration. F equals m times a. You could also say the more mass an object has and the more acceleration that it has, the more force that it has. You could say that an object with a very small amount of mass but a high acceleration can still have a great amount of force associated with it. All right, and then going all the way back to Newton's third law. So remember the third law, you have two objects, right? So I know everyone knows for every action there is an equal and opposite reaction. So when we were talking about these laws, we were talking about maybe you place a book on the table, right? The book, it's resting downward on the table. There's a downward force on the table. That's the action force. But the reaction force is the table holding the book up. So my apologies, the arrows should be the same size because remember it's equal, and they are in opposite directions because it's opposite. So remember there was always an action and a reaction force. There are two objects at play. The book applies force on the table applies force back on the book. All right, thanks for sorry, one more slide. I almost wanted to end too soon. All right, last slide. So let's talk one more time about unbalanced and balanced forces in terms of acceleration. So when we talk about balanced forces, remember net force is equal to 0 newtons. This does not cause an acceleration. So to prove it with our handy dandy new formula, remember our formula is F equals ma. So our proof, let's plug in. If it's a balanced force, the force would be 0, right? So we plug in 0. Equals, what's our mass? Well, we're just going to make up a mass. This mass is going to be 2 kilograms. And then times acceleration. So we're going to end up solving for this acceleration, okay? So when we need to solve for this acceleration, we need to get a on a side by itself. So right now it's being multiplied by 2 kilograms. So we need to divide by 2 kilograms. this will cancel it out on this side, and what we do to that side, we definitely still have to do to this side. So we have to divide by the 2 kilograms on the left-hand side. So we end up having 0 divided by 2 kilograms. 0 divided by anything is 0, so yes, indeed, our acceleration is 0 meters per second squared. Remember, it's second squared. All right, so if we have any kind of balanced forces, with the net force is 0, there is no acceleration. And of course, on the other hand, if we have unbalanced forces, where our net force is any number greater than 0, could be 1, 10, 150, and it acts on an object, it does cause an acceleration. So, of course, let's prove it. So, net force, anything greater than 0. I picked 4. So if we have 4 newtons equals the mass, well, I just use the same mass as before. Maybe it's a ball that weighs 2 kilograms. So plug in 2 kilograms, and it's multiplied by acceleration. So again, we're solving for this acceleration, trying to determine what might the acceleration be in this situation. So again, we have to divide by 2 kilograms, divide by 2 kilograms. On this side, it cancels out. So we have acceleration is equal to 4 divided by 2. 4 divided by 2 is 2. So our acceleration is 2 meters per second squared. So we are accelerating. 2 meters per second squared just means that the object is increasing its speed by 2 meters per second every second. So the pattern would be 0, 2, 4, 6, 8, 10 meters per second, and so on. So it's increasing in speed, just a little bit, but it is increasing in speed, so it is accelerating. All right, last thing. The bigger the unbalanced force acting on the object, the bigger the acceleration of the object. So before, what was our unbalanced force? Well, for me, I used 4 newtons. Let's do something bigger than that. So let's use an unbalanced force of 16. That's a good bit bigger. So 16 newtons is equal to our mass. We're still talking about this 2 kilogram make-believe ball, 2 kilograms, times acceleration. We're going to solve for the acceleration. So we're going to divide 2 kilograms on each side. It's going to cancel out on our right side. So we're going to be left with acceleration is equal to 16 divided by 2. 16 divided by 2 is 8. So our acceleration is 8 meters per second squared. So yeah, we were right. If you increase that unbalanced force, so our unbalanced force went from 4 to 16, then yeah, you do have a bigger acceleration because we went from 2 to 8. So much bigger. All right, thanks for watching. If you have any questions, leave a comment.